we go. Hello, everyone. Great to have you all with us. It was super important for us to host this webinar today. I'm Bchiri. I'm the president of XRPL Commons. I'm here with Mélanie Damour, who's our head of strategic initiatives. We have online our friends from the Crypto Carbon Rating Institute, Uli Gallersdörfer and Christian Stoll, the two co-founders of CCRI. We're going to explain to you today how we can elaborate collectively as a community decarbonization strategy for the XRPL protocol. For a number of reasons, it's important to not only take part in this initiative, but also understand the global, what's at stake in the global scope of what's a protocol carbon footprint. When we talk about it, it implies a lot of concepts. And so we wanted to have this first webinar, which will be the first of a series of webinars. And this first one will be about giving a broad approach of what a carbon footprint is for a protocol, how we measure it, and also, even before that, giving you a number of items and concepts that we should all be aware of about, what's at stake in global change, in global warming and climate change. How can we improve collectively the impact of the XRP ledger, not only by using the XRP ledger, but also by improving the efficiency of the protocol itself. So without further ado, I'm going to let Mélanie introduce you to this global approach that we're trying to elaborate and share with you the first steps, our first steps into this mission.
Thanks, David. Hi, everyone. So my name is Mélanie Damour. I'll be presenting the first part of this webinar. A bit more on my background. I've worked more than 8 years in strategy consulting across different sustainability topics. For example, I led the decarbonization strategy for a top French industrial leader here in France. And I recently joined XRPL Commons as the head of strategic initiatives with the objective to help grow the XRPL community. So 2 objectives for today's webinar. The first one is to help you understand key decarbonization concepts and their implications for the XRP ledger. The second objective is to introduce CCRI, present here today, and their approach to assess the XRP ledger's carbon footprint. I'll kick off this webinar with an introduction of key concepts behind climate change. So for the past 10,000 years, climate has been stable. It's only been the past 100 years where things have started to change. This is directly related to the massive increase in the use of fossil fuels and cement since the 1900s. All of this has led to a drastic increase in CO2 emissions. The increase in CO2 emissions disrupts the carbon cycle. What is a carbon cycle, you may ask? It's a mix of 2 balancing processes. Firstly, carbon is released by carbon sources. Secondly, carbon is absorbed by carbon sinks, such as the ocean, forests, and soil. All of this creates a natural carbon balance. However, the massive increase in CO2 emissions disrupts the carbon cycles and nature's ability to absorb carbon. Indeed, only half of the CO2 produced through human activity is absorbed by the Earth's carbon sinks. The rest is trapped in the Earth's atmosphere. As CO2 emissions are trapped in the atmosphere, this also traps heat, which in turn warms the planet. This is basically the main driver to climate change. Rising temperatures have very strong impacts on our planet, as you already know. This leads to more frequent extreme weather events and also drives changes to weather patterns. All of these consequences threaten our delicate ecosystems, but also have negative impacts on people and the economy. Given the negative impacts of climate change, there's an overall call to action for stakeholders worldwide to limit the temperature rise well below 2 degrees and if possible, below 1.5 degrees in alignment with the 2015 Paris Agreement. Basically, this corresponds to a 6% drop in global emissions on an annual basis. So how can we do this? Firstly, there's a lot you can do at the individual level. French citizens, for example, should divide by 5 their carbon footprint by 2050 in order to be aligned with the Paris Agreement goals. There's also a lot that can be done at the country level. France, for example, should divide by 6 in its emissions and multiply carbon sinks by 2 by 2050. For today's webinar, we'll focus on what can be done at the corporate level. So regarding a company's impact on the climate is basically equal to the CO2 emissions generated by its activities. When we say CO2 emissions, we actually mean all greenhouse gases, but for simplicity, we count in CO2 equivalent, or CO2e. Emission sources are classified per activity, by category, and by scope. There are 3 types of carbon emission scopes. Scope 1 represents emissions directly produced by the company for which they have full control over. For example, this can be emissions from company facilities and company vehicles. Scope 2 represents all remaining sources of emissions at the company level. This can mean energy consumption not related to combustion, but also heating and cooling systems. Scope 3 represents all remaining sources of emissions for upstream and downstream activities. For upstream activities, you could have, for example, purchased goods, also capital goods, and waste from operations. For downstream activities, you could have end-of-life treatment of sold products, transportation, and distribution. So once you've identified the sources of carbon emissions, you need, as a company, to estimate your carbon footprint. To do so, at the company level, you should start by listing all the activities induced by the company. So here in our example, we have heating offices, buying computer equipment, and air travel. Then you need to collect data in terms of overall annual volumes. Thirdly, you need to find an emission factor per unit. And finally, you need to multiply and add all the previous items to get the total carbon footprint at the company level. So once you've understood where emissions come from, then you can formulate your decarbonization strategy. To introduce what is a decarbonization strategy, I'll use a running analogy. So firstly, as an individual, you might want to set for yourself a long-term ambition to run and finish a marathon, for example. For this ambition, you'll need to define under what time you want to complete the race, which is your target. In our example, this could mean running a marathon under 4 hours. To help you reach this long-term ambition, you need to have a near-term commitment to help you prepare. This could be running a semi-marathon under 2 hours, for example. And finally, to help you reach these milestones, you'll need a tested and approved training approach. This could mean joining a running group, for example. In terms of decarbonization at a company level, whether a company is listed or not, you can set a long-term ambition to reduce carbon emissions and be either carbon neutral, net zero, carbon negative, and even zero carbon. Setting out what year you want to reach your ambition is basically your target. This could be, for example, reaching net zero in 2050. To reach this long-term ambition, you need to have a near-term commitment to help you prepare. This could be, for example, reducing CO2 emissions by 28% across scopes 1, 2, and 3 by 2030. To help you reach these milestones, you can leverage a framework with a tested and approved approach, and this could, for example, be SBTi, the Science-Based Targets. We'll walk through together the steps of a company aiming to reach net zero in 2050. For this, the company needs to start building their baseline, which is the business as usual greenhouse gas emissions. Step 1, at the company level would be avoiding activities that emit carbon, either by changing business model or by using carbon reduction levers. This helps you produce less gross emissions, basically. Step 2 would be to use different CO2 emission compensation levers. This will help you decrease gross emissions to reach net emissions. In our case, net emissions will be below 0. Step 3 is reaching net zero. Net zero is basically equivalent to the point in time where net emissions are 0. It's also the accumulation of both reduction and compensation levers. So looking at decarbonization levers, there are basically 4 types, which range from the most favored to the least favored. For the first type of lever, you have avoid. This means avoiding carbon-intensive activities. It can be done through enhanced efficiency and processes. The second type of lever is reduce. This means changing activities to reduce emissions. For example, for scope 1 and 2, this could mean shifting to renewable energy and using natural refrigerants. For scope 3, this could mean supplier engagements. The third type of lever is remove and sequester. This means undertaking direct activities to remove and store residual emissions. You could have natural solutions such as tree reforestation, but also technological solutions such as direct air capture. Finally, you have offsets. This means offsetting residual emissions through indirect investments such as carbon credits. Yet generally, you have either removal credits or avoidance credits. Just so you know, the difference between remove and sequester, so lever number 3, and offsets is whether you do it directly or indirectly. For now, I'm going to zoom in a bit more into offsetting and what it means. So there are generally 2 types of offsets, removal credits and avoidance credits. Removal credits are projects that pull existing carbon out of the atmosphere. It can remove carbon permanently, but generally projects take longer to implement and are more expensive. You have both natural methods, such as tree growth, but also technological methods, such as direct air capture. This means removing carbon directly from the air through chemical processes and storing it underground. You also have avoidance credits. These are projects that reduce future emissions by preventing their release into the atmosphere. It enables to cut carbon at its source and protects carbon sinks. Usually, these projects have faster implementation timelines and lower costs. Examples you could find are stopping the conversion of grasslands to croplands. It could also be limiting timber harvest levels. So to compare and assess offsets, you can go through 9 types of principles. The first one is transparency. Does a project exist? Does it contribute to decrease emissions? Alignment. Are the projects aligned with the company's vision, strategy, and value chain? Additionality. Does buying an offset lead to a change that would not have happened otherwise? Verifiability. Can the projects be verified by a third party? Leakage. Does the project decrease emissions in one location but increase emissions in another location? You can also have double counting. Across the different stakeholders involved, who can claim the emissions reduction? Principle number 7, acceptability. Are the offsets used credible and impactful? Number 8, durability. Does the project result in emissions reduction for a durable period of time? And finally, cutoffs. Does the project result in emissions reduction in the same period the emissions were emitted? So if we go back to companies' decarbonization strategies, we can deep dive a bit more into the different levels of long-term ambition. These range from the least impact to the most impact on greenhouse gas emissions reduction, with carbon neutral, net zero, carbon negative, and zero carbon. I'll explain each level, in a bit more detail. On this slide, you have some examples of companies that have set each level of emission. Zero carbon, just so you know, is theoretically impossible at the company level, but can be reached within activities. So for carbon neutral, you start with assessing your business as usual carbon footprint. You go through step 1, which is to use carbon reduction levers to produce less gross emissions. You also go through step 2, which is to compensate residual emissions to lower net emissions. So for carbon neutral ambition, net emissions are above 0. Net zero carbon. You also start with your business as usual carbon footprint. Step 1, you use carbon reduction levers to produce less gross emissions. Step 2, you compensate residual emissions to lower net emissions. As we mentioned earlier, net zero is basically a point in time where net emissions equal 0. In our case, emissions are still being emitted, but an equal amount is being removed. This is generally for best-in-class companies. Then you have carbon negative. You start with your business as usual carbon footprint. You go through step 1 with carbon reduction levers, step 2 to compensate residual emissions to lower net emissions. And carbon negative is basically when net emissions fall below 0. It's basically beyond net zero. This means removing more greenhouse gas emissions than what is produced. Finally, for zero carbon, you start with your business as usual carbon footprint. You go through step 1 to use carbon reduction levers, and at one point, gross emissions equal 0. As I said earlier, no company can theoretically achieve this status, but some activities within a company can. So looking at the long-term ambitions from least complex to most complex to implement, you have carbon neutral, net zero, carbon negative, and zero carbon. In terms of levers you can use to decarbonize, carbon neutral generally allows all types of levers. However, net zero and carbon negative only favor avoid, reduce, and removal levers. Zero carbon only allows avoidance levers. When a company sets a climate commitment, it should be feasible, credible, and limit the use of offsets. In the case of the XRPL protocol, our pledge is to commit to a carbon neutral ambition. So to finish the explanation on decarbonization strategies, there are tested and approved frameworks that can help you achieve your long-term ambition as a company. There is SBTi, which are based off science-based targets and provide companies with a clear framework to reduce emissions in line with the Paris Agreement goals. This gives company credibility and drives investor confidence. It also provides a company with tools, expertise, and support from technical experts to reach its target. It is considered today the international standard. There are, however, other frameworks that exist, for example, the Label Bas Carbone, and also the Net Zero Initiative and the ACT. So for the second part of this webinar, we'll do a short focus on digital companies and blockchain. So digital technologies can both be a problem and a solution. Globally, the digital sector emits around 4% of global greenhouse gas emissions. Manufacturing new equipment represents around 40% of emissions, and powering equipment represents 60% of emissions. In 2025, it's expected that the emissions of the digital sector could reach up to 8% of all emissions. All of this is hardly compatible with the Paris Agreement. That's why there's today a call to action, especially regarding digital companies, to limit emissions, and this includes blockchain. So if we have a look at the blockchain value chain, we'll try to understand what are the main sources of greenhouse gas emissions. Firstly, running servers is very energy intensive and can be fossil fuel based depending on your energy mix. Cooling servers also requires a lot of water. This also can use refrigerants, which are highly polluting. Secondly, running a blockchain requires electronic components which have high environmental impacts in terms of raw materials extraction and also end-of-life treatment. Finally, building sites to host blockchain-based activities also has impacts in terms of soil artificialization. So what about the XRPL protocol? The different topics discussed today bring us to our pledge to decarbonize the XRP ledger. All of this starts with assessing its carbon footprints, which is currently being done by the Cryptocarbons Ratings Institute.
So before handing over to Christian and Uli, I will just pause here for a second just to make sure we're all aligned. We described to you the framework by which generally all projects are being qualified in terms of decarbonization strategy, and where exactly we will see the XRP ledger fall into is the next conversation we're going to have all together. Now, we're handing over the microphone to CCRI because we felt it was very important for the XRPL community to rely on a third party that would be trustable, that would be neutral, and that would be able to assess the carbon footprint of the protocol in the same way they've done for other chains. So without further ado, Christian, you can take over.
Thank you, David, for the warm intro, and Mélanie for setting the stage. Hi, everyone. My name is Christian Stoll, co-founder of CCRI. And in the next couple of minutes, I will present together with Uli, who's also a co-founder of CCRI, who we are, what we do, and our approach to assess the XRPL ledger. In terms of the agenda for the next couple of minutes, we have 4 agenda points. So first of all, we will start to explain why we need reliable crypto climate impact data specifically. Second, we will provide a bit of background about ourselves, so what we do and who we are at CCRI. Before third, double-clicking on our approach and first results to assess the XRPL ledger. And last, we will provide you with an outlook and some implications of the assessment results. Jumping in directly, so why do we actually need reliable crypto climate impact data? And we see basically 3 narratives at the moment. So historically, there was quite a negative narrative around blockchain, driven by the significant emissions caused by blockchain mining, such as the Bitcoin network and also historically Ethereum. Over the past 1 or 2 years, I would say the narrative has shifted slightly as more and more energy efficient protocols have appeared, and blockchain is increasingly seen also as a solution to fight climate change by tokenizing carbon credits, by supply chain tracking and other applications. And third, what's now really driving the demand for reliable crypto climate impact data are regulators, which are doubling down globally on disclosure of climate impacts. So some of you might be familiar with the EU MiCA regulation, which has a very strong sustainability disclosure mandate. So that's now really becoming more and more important for the industry to double down on this topic. So why is it now specifically important for XRPL to assess its carbon footprints? Basically, four topics come to mind from our perspective. First and foremost, it remains a differentiator to be energy efficient, as this is kind of a key decision criteria for corporates, developers, and other stakeholders to engage with a respective protocol. Second, as mentioned by Mélanie and David, having clarity and transparency also forms the basis for mitigation. So having a proper database is the starting point to achieve corporate climate goals via the respective levers. Third, it's a question of transparency to assess the carbon footprint and disclose the respective climate impacts to the general public, to regulators, policymakers, and others that want to know about the costs and benefits of the XRPL ledger. And last, it's a topic of regulations. As I already mentioned, compliance topics such as disclosure of climate impacts on the EU MiCA are becoming more and more important and increasingly mandatory globally. So what does our solution look like? We, from CCRI, we measure the electricity consumption of blockchain nodes. So we have a lab with a controlled environment in Munich where we run own nodes to measure the electricity consumption on a representative hardware set. We use this data to model the carbon footprint of the entire networks in real time based on transaction volumes, node counts, node locations, and the respective electricity used at the respective locations. Third, we are capable to allocate those network emissions to single user activities, and user activities can also be layer 2 networks, all types of tokens that build on top of those networks. And last, we support in analyzing the emissions and implications as a basis for carbon accounting, mitigation strategies, and other ESG-related considerations. On the right-hand side of the chart, you can see a sample of existing customers. So in the past, we've worked with large tech companies, such as Microsoft and Salesforce. Core of what we do is working with blockchain networks directly. So we were mandated, for instance, last year to measure before and after the merged electricity consumption. And we've worked with quite some leading players in the field, as mentioned by David, to have a comparable data set with a harmonized methodology and a standardized approach. We also work with crypto users and investors directly to support them with their carbon accounting obligations and to gain transparency on their climate impacts. And our data is also increasingly used by other data providers, such as carbon accountants or other index product providers. And last but not least, also by universities such as Cambridge University, which builds their real-time indices on our measurement values. In terms of our history, so where do we come from? The CCRI team started over 7 years ago as researchers. So all of us were at TU Munich and MIT at one point in time. And we jointly published our first major paper in 2019, which reached over 1 billion views globally, including statements on CNN. And this translated 2 years later in 2021 into first commercial requests. So in 2021 was a time when Tesla was exploring Bitcoin payments and the first ETFs appeared in Canada and South America. People asked for up-to-date data on the papers that we had published. And that's how we started CCRI, to benchmark crypto assets, to provide clarity how to account for the carbon emissions. And this year, our focus was really to expand our coin coverage, double click on the topic of ESG performance of crypto assets. And going forward, we want to remain the #1 crypto sustainability data provider. On the next slide, you can see our data set. So at the moment, as of today, we are the only provider of crypto sustainability indicators. And currently we track 27 coins and tokens on a daily basis. And as you can see on the slide, we will start covering XRPL soon based on the assessment that we are currently conducting. So what are we actually assessing to kind of connect with the presentation of Mélanie? So we are really focused on electricity consumption of the network itself, so while in operation, and we focus on validators' electricity consumption of the mainnet in this case. So we do not consider block explorers, query nodes, full nodes, testnets, and the like, but in line with, for instance, the MiCA regulation, we really want to focus on the core infrastructure and what is needed to run the core infrastructure. So that's why we set this scope here. What we do exactly, on the next couple of slides, I would hand over to Uli to guide you through our steps of this network assessment. Uli, over to you.
Thanks so much, Christian. Our methodology is based on 5 key steps, and we will do a deep dive on each one of them. First, we select the network, the hardware, by analyzing the network and its minimum hardware requirements. We actually set up nodes and measure the electricity consumption, which we then use to translate into the total electricity consumption of the network, while also deriving performance metrics such as the marginal electricity consumption per transaction, as well as coming up with an overall carbon footprint by assessing node locations. So let's jump into the first 2 points here. Slide, please. We have a temperature controlled room in Munich in which we house 6 different devices. This is our device set. It has been with us for all our network assessments. And depending on the hardware requirements of the individual blockchain networks, we select a subset of these 6 devices. And this allows us to ensure compatibility between all many blockchain networks. It's the same methodology for the networks, and we're able to benchmark against each other. In the second step, we set up the nodes, we configure them, we sync them. So we are waiting for them to get fully synced. We monitor their logs, we monitor their process blocks, their transaction throughput, and at the same time, with verified hardware, we are measuring the electricity consumption of these devices. In the third step, we are focusing on the electricity consumption of the overall network. So we have these individual measurements of each individual device, and we create a best guess device by individually weighting the different computer devices. So if you have data on the type of hardware you use, please feel free to share this with us, because then we're able to bet the balance between these individual devices. When we have this this best guess estimate, we're able to multiply this with the total node count to in these estimates. It's always, or in our methodology, it's always about the validator counts to derive at the total network electricity consumption. In the fourth step, we are calculating performance metrics such as the power per node or the marginal power demand per transactions, and benchmark these against other peers. So if you look on the right-hand side, this is a measurement and the data points of the electricity consumption of one device in line with its transaction count. And as you can see, the data points are a little bit separated in 2 buckets. And this is given is due to the periodic pruning of these nodes. So the online deletion of past ledgers, which is standardized within 512 ledgers to be deleted after that somehow, or that increases the electricity consumption for the device only on a short period of time. But we assume that as default it is turned on, and if you know otherwise for your machine, also please let us know. And the last step,
sorry, but this is a clear invitation to the community of validators to participate in that assessment. We're doing sort of a sampling of the topology of the network, but if we could work also with real data from validators from the community, we're very happy to onboard every one of you in this process.
Definitely. Thanks so much. As in the last step, we assess the carbon footprint of the network. So we collect node locations from the XRPL.org website, and use also location-specific emission factors from the International Energy Agency. So they provide data on the carbon intensity of electricity grids in the respective locations. And with that, we're able to calculate a XRPL-specific carbon intensity to translate the previously calculated network electricity consumption to the network carbon footprint. And again, any information that you can share with us on the location of your validators would help us to enhance our estimate here. That's the preliminary result here of our assessment here. And what you can see here is the, so to say, the benchmarking of these individual values to a peer group of other cryptocurrency networks. So you can see the carbon intensity of the XRPL ledger is a little bit higher than the benchmark group. The power per node is also a little bit above the peer group, but for the marginal power demand per transactions, XRPL is above the pack. It's lower there. It's better, so to say. Okay, that's about our methodology here. and I would hand back over to Christian for the next steps.
Thanks, Uli. In terms of the last part of our presentation, besides our data forming the basis for corporate climate action, as explained by Mélanie, we want to highlight two potential use cases to build on top of our data. And the first one is that our assessment forms the basis for potential web sustainability dashboards. So as you can see on this mock-up, building on our data, building on the daily available data and the granularity, our data forms the basis for such a web sustainability dashboard to display the global footprints, the carbon intensity, electricity consumption of the network, and educate potential stakeholders around comparisons of those emissions to real-world examples such as flight emissions or household-level electricity consumption. That's one application. In terms of the second application, you might be aware of the MiCA regulation, as I already mentioned, which has been approved and will start applying in 2024. On this roadmap, you can see where we are currently in this process. So the MiCA has been approved, and the ESMA, the European Security and Markets Authority, is currently developing the technical standards, how to implement it. And the MiCA will set a EU-wide framework to harmonize crypto asset regulation, and sustainability disclosure is a focus area in the MiCA. And consequently, what the MiCA entails is that all token issuers and any type of crypto asset service provider will have to disclose environmental impacts. And we are currently the only provider of such sustainability indicators. And our assessment, looking at the marginal electricity consumption of single transactions, looking at carbon intensity, etc., forms the basis to comply with this upcoming mandatory reporting obligations, which you can see on the next page will be quite granular. So currently the ESMA is proposing to disclose 10 indicators across the domains of energy, GHG emissions, waste production, and natural resources that have to be disclosed starting in 2024, underpinned by respective quantitative metrics. So that's, I would say, really a game changer for the industry. To be in a position to have to disclose on such a granular level. But given the transparent nature of blockchain, I'm quite confident that the industry will manage and can really also set an example for other industries. So having said that, as a last word from our side, thanks a lot for having us, XRPL Commons team. Pleasure meeting everyone on the call. If you have any feedback, comments, please reach out, and happy to engage directly. Many thanks, and back to you, David and Mélanie.
Thank you so much, Uli and Christian. So as you understand, it's really the first steps for us in elaborating the decarbonization strategy for the protocol. We are coming very humbly to the community, knowing that there are many people involved, the community of validators, the people who are building on top of the XRP ledger. And you know, one bold approach would be to say, well, let's find a place where the electricity has the smallest carbon footprint and move all the servers there. But we also have to be mindful that we are a decentralized protocol, so we want to keep that decentralization, as a first, as the foundation of everything we do as a community. So it's more complicated than just improving with one magical wand. So we say we cannot improve something we cannot measure. So for Commons, it was the first step to engage in a process that will allow us to measure, assess, and then make available this assessment publicly, transparently, either on our website or on xrpl.org. This data will be made available and updated on a daily basis, and we're in an agreement with CCRI, so we'll keep this data afloat and updated on a regular basis. We are now open to questions. If there are questions we can address right now on the fly, we'll do it. If these questions require more research from our side, we will make sure we address them in the next session. So we have a question from Boone. can we use the data and report to DEED on XRPL in our reporting? So the answer is yes, and please do so. This is an open data approach. So all the data that will be made available through the dashboard will be downloadable in a CSV format, so you can reuse them, you can, audit them, you can run a counter audit of them. I mean, this is made in a way that we're trying to improve collectively. So the first step is, of course, to make them available and easy for you to use and query. And then we'll try to keep this set of data as a snapshot from today, and then do the same thing again in 6 months, see if whatever strategy we put in place as a community later has an impact on the protocol itself. Other question from Arik, how do you measure how each validator or node is sourcing its electricity? There was a reference to that, but I will let Christian or Uli answer that question.
Happy to take that question. Thanks a lot for the question. In carbon accounting, there are two complementary approaches how you can translate electricity consumption into carbon emissions. And the first one is a location-based carbon accounting, and the second one is a market-based carbon accounting. So if we know, we follow currently the first one, in location-based carbon accounting. So if we know the node locations from those maps that Uli showed, we can derive for the respective electricity grid the average carbon emissions of the electricity consumed and apply those factors to translate the electricity consumption into carbon emissions. The second approach, the market-based approach, would also include if a certain validator is purchasing respective credits or renewable energy certificates. That's an approach which we currently cannot apply because we don't have the data for all validators available. But this is something that is a future avenue for research. So therefore, for now, we rely on the location-based carbon accounting. I hope that answered your question.
And the data you use are like commonly used average provided by the electricity. I don't remember the name of this.
International Energy Agency, exactly. So that's kind of the gold standard for those kind of emission factors.
Any other question that may come later, you can address them by email, and we will send the follow-up to all the participants with a link to this webinar as a replay. We have another question is coming. Is the data based on the global averages or local variations are also considered?
So our data set goes down to country level emission factors. And in some instances, such as the US, we also have emission factors on a state level, as those differ quite significantly. And for Bitcoin, for instance, in the past, we had a similar approach for China to have province-specific emission factors and also variations over the course of the year. So we try to use emission factors as granular as possible to capture the location-based emissions as accurately as possible.
And as we mentioned earlier, we would love to work with actual validators from the community to, get a more granular data of their location, their hosting solutions, their hardware solutions. Whatever information we can document and use to get a more precise and refined data set would be awesome for the community. All right, I would like to really, from the bottom of my heart, thank you two guys from the CCRI Crypto Carbon Rating Institute. It's a pleasure to work with you. Also, I want to thank Mélanie, who brought, she packs a lot of expertise in that field, and we're very lucky to have you on board with us. We hope you had, a few insightful information about what we're trying to do right now. And we're going to host another meeting probably early 2024. And in the meantime, we're very available for you to engage with us on our socials or by email. Thank you all so much.